In 2015, there was huge excitement in the space community. That is because, up until then, the best image we had of the Pluto system was this. Hubble also squinted its lens at Pluto, but it is so small and distant, the best it could see was a few blobs of color variation. But in 2015, this all changed. That is because after a 9-year journey, the New Horizons space probe flew by the dwarf planet, giving us a detail and fidelity of Pluto and its moons like we had never seen before. So, the question is, what did the New Horizons probe see and discover during its flyby of the Pluto system? And what has it been doing since the flyby? I'm Alex Wakulgan, and you're watching Astrum. Stick with me in this video, and I will show you all the highlights from the New Horizons mission to the Pluto system and beyond. Let's first of all give you a quick bit of context in case you are new to Pluto or if it's been a while since you last heard about it. Pluto is a remarkably pretty, tiny world, much smaller than our moon. It's found in the Kuiper belt, a dispersed belt of asteroid or comet-type objects beyond the orbit of Neptune. Pluto was the last of the traditional 9 planets to be explored. This was due to its distance from us, but also because, can you believe this, it wasn't considered a very interesting celestial object. Thankfully, the team behind the probe pushed hard for this mission to be approved, and in 2006, New Horizons was launched as part of NASA's New Frontier program for medium-budget space missions. The goal of the mission was to get to Pluto as soon as possible, and as such, New Horizons was the fastest launch ever, it being a light spacecraft on the most powerful rocket available at the time of fully boosted LSV. It whizzed past the moon in only 9 hours. The Apollo missions took 10 times as long. On its way to Pluto, it used Jupiter as a gravity assist, which shaved 3 years off the arrival time. It also used Jupiter as a trial run for its systems, taking some remarkable videos and images of the planet and its moons. After this successful trial, New Horizons went into hibernation mode to prevent the wear and tear of its instruments. Leading up to its approach in 2015, the team turned the systems back online, and every day the spacecraft sent back images of the Pluto system. This was an incredibly exciting time for enthusiasts following the story. We began to get hints of what Pluto could possibly look like and saw how different Pluto was from its biggest moon, Charon. Every day, the resolution got higher and higher, and more details could be made out. Yes, there were other scientific goals for the mission, but the most interesting thing to me was what it looked like. Soon there could be seen what looked to be a heart shape on the dwarf planet. On the 14th of July, the New Horizons probe made its closest approach, at only 12,500 km from the surface of Pluto. However, mission controllers didn't get a look straight away. Firstly, the probe was too busy taking a lot of photos during the flyby to send any back immediately. Once data transfer commenced, they had to deal with the slow uplink speed of only 1 kbit/sec. Further to that, there was a 4.5-hour latency between the spacecraft and the Earth. But what it saw and sent back was spectacular: mountain ranges, ice plains, glaciers, and an atmosphere. It also had a good look at some of Pluto's moons. Let's go into detail about what it actually discovered during this flyby. One of the first things observed about Pluto is its unusual relationship with its moons. For a start, Pluto's biggest moon, Charon, orbits very closely to Pluto and is also very big in comparison. This means that the barycenter of the two objects, or in other words, their center of mass, is outside of the primary object. They actually both orbit around a point in space. Not only that, but both objects are tidally locked to each other. This means that if you stand on one, the other won't move from that point in the sky. This is very unusual, because while some moons are tidally locked to their parent planet, the planet is not also tidally locked to the moon. Charon is very different visually from Pluto, being much darker. This implies they are not from the same origin. The rest of Pluto's moons are very small, only a few kilometers across. Their orbits are exceptionally circular and are all coplanar with Pluto's orbit. The geology of Pluto is very interesting. The biggest visible feature on Pluto is this giant heart shape, which wowed the world when it first came into view. It has since been named Sputnik Planitia. It is the size of Texas, and it has a strong color contrast to the surrounding area. This is because it is a giant ice plain. In fact, during the flyby, it was confirmed that 98% of Pluto's surface is composed of nitrogen ice. On average, the temperature on the surface of Pluto is 229 ig, which means water ice would be rigid and brittle. On the other hand, nitrogen ices at this temperature act like water ice on Earth, meaning it can flow as glaciers. This can especially be seen around the edge of the heart, with glaciers flowing into the gaps around the craters and mountain ranges. The ice plains themselves have giant polygon shapes across the entire area. There are also no craters, which means it must be a relatively new feature, or a feature that is being continually renewed. It is perhaps only 10 million years old. The polygonal cells show ridges on them which are likely caused by sublimation, the process of an ice turning directly into a gas. Ices sublimate and freeze here regularly, creating troughs and pits, meaning these polygons are likely to be convection cells. Cells are moving and can be seen pouring into the mountain ranges surrounding the region through slow, moving glaciers. Sputnik Planitia could be compared to Greenland and Antarctica, in that it controls the climate of Pluto heavily. Although it's not known for certain, Sputnik Planitia could have formed from an impact, and ices filled the crater in from a potential subsurface liquid ocean. This filled basin actually causes a positive gravitational anomaly. A gravitational anomaly is where the gravity at one point is different from elsewhere on the object. The ice plane is directly facing away from Charon, which would align it up with the object's tidal axis. Due to the short distance between Pluto and Charon, tidal effects are very strong on both objects. This could be the reason why Pluto is tidally locked to Charon, and the two objects can't look away from each other. Surrounding the ice plains are vast mountain ranges made of water ice, which, when viewed from the side on, look spectacular. Water ice is the only type of ice detected on Pluto that would be strong enough to support heights of several kilometers at this temperature. Among the mountains found on Pluto, there might also be some which are cryovolcanoes, one of the most likely candidates being Right Mons. It is 4 km tall, one of the highest peaks on Pluto, and a big depression is found in the center. Volcanoes could be a contributing factor for Pluto's young surface. Here is an extremely interesting region called Tartarus Dorsa. It is an extensive, highly distinctive set of 500-meter-high mountains that resembles snake skin or tree bark. They are thought to be penitentes. If that is true, Pluto is the only place in our solar system other than Earth where they have been observed. Even on Earth, they are very rare, but some can be found in the Atacama Desert and other dry, high-altitude regions. The ones on Pluto are much taller and cover a much vaster area than on Earth. We can only imagine what they look like close up. Another obvious feature of Pluto is the dark material that seems to be sprinkled on the surface in some areas. The biggest such area is called Cthulhu Macula. It is weirdly reminiscent of a whale in shape, as can be seen in this image. The region on Pluto is much more heavily cratered than the heart, which implies the surface there is much older. Mountain ranges can be seen in the middle of Cthulhu Macula, topped with what is thought to be methane ices. Methane apparently condenses as frost at higher altitudes on Pluto. The dark color is thought to be a deposit of tholins, a kind of tar made up of hydrocarbons that have interacted with sunlight. Similar deposits can be seen on one of Saturn's moons, Apatus, so the process has been seen elsewhere in the solar system. Scientists suspected the substance was tholins as soon as New Horizons started sending images back, but its distribution over Pluto's surface was baffling. Why are only some areas covered? Also, how dynamic are the processes surrounding the distribution of tholins? Has Pluto looked like this for a while? Or is this a changing environment? It turns out that these tholins may well be connected to the cryovolcanism found on Pluto. Pluto is one of the few objects in our solar system where cryovolcanoes are actively shaping its surface. Water from either the mantle or from pockets of water trapped in the crust erupts over the surface of Pluto, creating a varied landscape. But it turns out that it's not just water found in these eruptions, but tholins are clearly mixed in too. Data from Hubble suggested that Pluto was getting redder, and New Horizons may have passed by during Pluto's reddest time of its year. And New Horizons may have found out why. Here in a region called Viking Terror, we see a cryovolcano that fountained this water tholin slurry across the immediate surroundings. Just next to this region, we see a crater and a trough filled by this slurry during another eruption. By the trough, you can see where this slurry flowed down and pooled. This can also be seen in another region by Virgil Fossae, another trough where this slurry has traveled down. However, the most interesting thing about tholins is not found on Pluto itself, but rather on its twin dwarf planet, Charon. In this enhanced color image of Charon, what do you immediately notice? The red cap over its north pole. Incredibly, because Pluto's gravity is so weak, when it erupts this slurry mixture, some of it escapes Pluto altogether and makes the 19,000 journey to Charon. The tholins are localized here because Pluto and Charon are tidally locked to each other. They only ever show each other one face. Poetically speaking, Pluto is always hiding its heart from Charon in this eternal waltz. This means that more tholins fall on a specific spot on Charon, rather than all over. And speaking of Charon, some interesting discoveries have been made about it too. It is a water ice world, unlike Pluto, whose surface is predominantly nitrogen ice. As such, it doesn't really have an atmosphere like Pluto does, as the water ice is locked to the surface. On Pluto, the nitrogen ice sublimates depending on Pluto's seasons, meaning Pluto's atmospheric density can vary by many orders of magnitude over the course of its year. With this sublimating and refreezing of the atmosphere, Pluto's appearance may change dramatically over the course of its 248-year-long seasonal cycle. For me, the most impressive discovery that New Horizons was able to confirm was that Pluto has an atmosphere. And not only that, but the images are incredible. Due to Pluto's small size and weak gravity, the atmosphere appears to extend high above the surface of Pluto, Earth's atmosphere, while being much more massive and dense compared to Pluto, hugs the planets comparatively tightly as the gravity is a lot stronger. The atmospheric pressure on Pluto, on the other hand, is exceptionally low, roughly 10 microbars or 100,000 1,000,000 times weaker than the surface pressure on Earth. It's theorized that the pressure could increase to as much as 18 to 280 millibars, 3 times the surface pressure on Mars and a quarter of the surface pressure on Earth. This may happen throughout Pluto's year. At some points in its orbit, it is closer to the Sun than Neptune. This would make the temperature rise, causing the surface ices to sublimate into gases, the process of which there is evidence of in the ice plains. But the last time Pluto was thought to have an atmospheric density similar to Mars was 900,000 years ago. At this pressure and temperature, the conditions could even be right for liquid nitrogen to form on Pluto's surface. Some evidence of this might be found here, in what appears to be a frozen river lake. At any rate, within just 1 year, Pluto's atmospheric density can vary by a factor of 4 due to seasonal variations. That is a massive contrast compared to other solar system objects with atmospheres, which generally stay pretty consistent. The atmosphere consists of the same ices found condensed on the surface, namely nitrogen, methane, and carbon monoxide. The other fascinating discovery New Horizons made about the atmosphere is that it has up to 20 haze layers. Haze layers themselves were not unexpected, but the amount of them was. They can clearly be seen in some of these images, acting like layers of a thin kind of fog. Sunlight can be seen streaming through one such layer in this photo, the shadows from the mountains clearly seen in contrast to the sunlight shining through the haze. The layers do not appear to be level across the planet. Here you can see this haze layer high above the surface, but on this side of the image, it touches the surface. On a side note, to me, these are the most breathtaking photos of Pluto, and I purposefully saved them until last. You can truly appreciate the depth and the scale of the mountain ranges. Pluto almost seems like a toy replica due to the extreme topographical relief, but these mountains appear so high because Pluto is so small and its gravity is not strong enough to pull them down. In June 2020, scientists released a paper stating that under Pluto's surface is believed to be an ocean of liquid water, very much like the icy moons of the gas planets. It was originally thought that Pluto formed cold, being so far away from the Sun. However, evidence from New Horizons suggests that this is not the case, but rather it started off hot. This means it's always had an ocean, and if that is true, then there is a case that habitability on Pluto may be just as good as habitability on the closer, icy moons. In fact, if Pluto is the standard for dwarf planets found in the Kuiper belt generally, there may be many more habitable worlds out there. How do we know it had a hot start? There is evidence of expansion, not contraction, on its surface. Its cracks show that the crust is moving apart, not folding over itself. If this is true and Pluto had a hot start, perhaps with bombardments from other planetesimals heating it up during the early stages of the solar system, it could be that shortly after it was formed, it would have had enough thermal energy that it was once an ocean world. This really puts a new perspective on how the solar system formed. While the total absence of craters is limited to Sputnik Planitia, it is amazing how few craters there are on Pluto and Charon generally. This might not just be because their surfaces are young, but perhaps the Kuiper belt is more devoid of smaller objects than we may have first thought. The flyby was over in a matter of days, and New Horizons started heading deep into the Kuiper belt. New Horizons had traveled so far from Earth at this point that when it looked at our closest star system, Alpha Centauri, it was in a clearly different place from New Horizons' perspective than from ours. This is due to the parallax effect, something I've done a video about here if you want to see more astronomical examples. It's just mind-boggling to me to think about how far New Horizons has traveled relative to us. so much so that Alpha Centauri has moved from New Horizons' perspective. Conversely, however, New Horizons has traveled all that way, and that's the only difference it's made to the view of our closest neighbor. Space is just so big. When New Horizons made its flyby of Pluto back in 2015, it barely slowed down at all. Its trajectory after the encounter actually took it further into the Kuiper Belt. Given that this region is so far from Earth, it is largely uncharted territory, a place where no man has gone before. So, did the New Horizons team know of an object they could visit next? Yes, they did. And its name is Arrokoth. But incredibly, they didn't even know of its existence before New Horizons was launched. So, what is Arrokoth? What does it look like? And what makes it unlike anything we have ever seen before? See, the year previous to the Pluto flyby, time had been given to the New Horizons team with the Hubble Space Telescope so that they could locate an object for New Horizons to visit after Pluto. Hubble actually discovered 3 new objects reasonably close to where New Horizons would be going, and after studying the data, the 35-long object now known as Arrokoth was chosen. As a result, Arrokoth would be the first object visited that was discovered after the spacecraft visiting it was launched. New Horizons was healthy and well after the Pluto flyby, with propellant left in its tank and years left in its rig, and so commands were quickly sent to New Horizons by the mission team to adjust its course so that it could rendezvous us with the promising new target. Being so small and far away, we didn't know much about the object. All Hubble could detect was its color and the dips and peaks in brightness as it rotated. However, scientists also observed Arrokoth's occultation of a star. Incredibly, from this occultation, they were able to predict the shape of Arrokoth, and as you will see later, this prediction was almost exactly right. At the very least, they knew it would be an elongated object, so potentially a contact binary or simply a long asteroid-type object. It was up to New Horizons to confirm their predictions. 3 years after leaving Pluto, in August 2018, New Horizons began its approach phase at a distance of 172 million kilometers. At this distance, Arrokoth was barely visible to New Horizons against the backdrop of distant stars. But by December 2018, it was bright in New Horizons' view. Traveling at 51,000 km, New Horizons was rapidly gaining on Arrokoth, and science data at this point was already beginning to be collected. As New Horizons got closer and closer, Arrokoth's shape could start to be resolved. It was bizarre looking, what appeared to be a contact binary, and it was relatively crater-free, with a lumpy surface. It was unlike any of the asteroids or comets we had ever seen up close before. On the 1st of January 2019, New Horizons made its closest approach at a distance of only 3,500 km from its surface, and it was on this day that it captured most of its science data. This flyby made Arrokoth the most distant object ever visited by a spacecraft, being 6.5 billion from the Sun at the time, or roughly 45 times further away than the Earth is from the Sun. Being this far away, the data transfer speed was abysmally slow between Earth and New Horizons at only 1 bit per second, although I will mention that it's incredible to me that the technology was there for them to communicate with New Horizons at all. This slow data transfer speed has meant that it's taken around 2 years to send all of the data it collected around Arrokoth back to Earth. The highest priority data was sent back first, namely the images, although I do remember at the time that the highest resolution images took a while to arrive back. Only low-resolution images were available when all the media outlets were publishing stories of the flyby, meaning I would guess that most of the general public never saw Arrokoth in all of its glory. So, here it is, the highest resolution images we have of this fascinating object, in true color. What you'll immediately notice about Arrokoth is that it is reddish in color, unlike most asteroids nearer to home, which are grayer and darker. It's red because of a similarity it shares with Pluto. It has an abundance of tholins on its surface. Tholins are organic compounds that have been broken down by solar and cosmic rays. Organic compounds on the surface probably included methane and ammonia at one point. However, Arrokoth does not have any of these substances left, probably due to its low mass. What Arrokoth's spectra does reveal is that it has methanol, hydrogen cyanide, and water ice on the surface. The abundance of methanol on Arrokoth's surface is the main factor behind its red color, as irradiated methanol is likely the cause of the tholins. However, there is a bit of a mystery in Arrokoth's spectra, as interestingly, there is also an absorption band at 1.8 min Arrokoth's spectra, and scientists do not know what this compound is. It is yet to be identified. It's nothing we've seen before. It's a shame we weren't able to get a sample of its surface to be able to say for sure. The next thing you'll notice about Arrokoth compared to asteroids closer to home is the absence of small impact craters. It is believed that this is due to the nature of the Kuiper belt itself. It could have 20,200 times the mass of our asteroid belt, but a lot of this mass is also contained within large Pluto-like bodies which dot the belt. While we can't say for sure what the population of the Kuiper belt is, it is definitely more spread out than our asteroid belt simply because it's 20 times as wide and has a much bigger circumference. Being this far from the Sun means orbital speeds are much slower, so even if an impact does occur, it will be at a low velocity. Meteorites you see creating shooting stars in the Earth's atmosphere may hit us at around 75 km, whereas impacts in the Kuiper belt may only be at speeds of 300 km. This depression here, which looks like a crater, may not actually have been formed from a collision, but it could be a sinkhole caused by the escape of volatile substances just under the surface. The lack of collisions means that what we see of Arrokoth now is like a time capsule from the early solar system, an object that has been preserved for billions of years. Although, a slow collision is one of the ways this object may have come into being. When asteroids in the asteroid belt impact each other at high speeds, they either cause craters or cause the body to completely fragment. But a slow collision, like those in the Kuiper belt, may cause both objects to simply merge. It may also be that the two lobes of Arrokoth formed side by side in a swirling cloud of ice fragments that coalesced into two orbiting bodies. Eventually, these bodies got closer and closer until they joined together. In any case, the merging would have happened very slowly because there really aren't many fractures and stress lines to speak of, so the max speed of the collision would be no more than 2 ms, plus the two objects would have also had to have been tidally locked to each other before merging too. The fact that both lobes of Arrokoth look very similar gives weight to the theory that they formed in the same region. Before Arrokoth got its formal designation, you may have known it by a different name, as it was originally nicknamed Ultima Thule. Now, the individual lobes are known as Ultima and Thule. You'll also notice some very bright regions on the surface. The ones in the crater are probably from avalanches as material fell inward after the sinkhole appeared. The other major bright patch is found around the connecting point between the two lobes. It's not known with certainty why this region is brighter, but theory suggests that this region sees the least amount of sunlight, so perhaps volatile substances can build up here like ammonia ice. It could also be that because this region would be the center of gravity of the object, loose material rolls down the lobes to collect in the center. With a density of only 0.58 m, Arrokoth is not going to be densely packed, but it is probably porous. Volatile materials would have escaped the interior of the object over time due to an internal heat source, but then these materials would freeze on the surface, leaving behind only rocky remains inside. This heat source can still be detected to some degree, as models suggested that Arrokoth should only be 12-14 Ga. However, New Horizons found that it was in fact 29 Ga. That is still extremely cold, just not quite as cold as we were expecting. There's one last mysterious characteristic of Arrokoth that isn't immediately apparent from these images, that only got discovered after trawling through the New Horizons data, and that is that Arrokoth is in fact much flatter than we would have expected. We didn't notice it at first, because Arrokoth rotates like this, meaning we didn't see too much of it lit up from a side angle. We don't really know why it's flat. Maybe it was due to centrifugal forces when the individual lobes formed, implying it was spinning a lot faster than it is today. Or maybe it's due to the way Arrokoth orbits and rotates, meaning one side of the object is constantly exposed to the sun for decades at a time. This would cause volatile substances to escape only on one side, until later in the year when the other side is exposed to the sun. Research is still underway to model the cause. As New Horizons left Arrokoth, it looked back and caught one last glimpse of its silhouette against the backdrop of stars. Who knows if Arrokoth will ever be visited again, so it may be that this is the last up-close view of it that we will ever have. What's next for New Horizons? Well, it still has life in its battery and a leaving of fuel still on board, so the hunt is now underway to search for any additional targets. Beyond that, it will follow in the path of the Voyagers, passing through the heliosphere of the solar system in the 2030s. Even if no other Kuiper belt object can be discovered close enough to its current trajectory that it can do a third flyby, the New Horizons team is already submitting proposals for an extended mission that will have a completely different focus. Want to convert New Horizons into a highly reductive observatory conducting planetary science, astrophysics and heliospheric observations that no other spacecraft can, simply because New Horizons is the only spacecraft in the Kuiper belt and the Sun's outer heliosphere and far enough away to perform some unique kinds of astrophysics. Those studies would range from unique new astronomical observations of Uranus, Neptune and dwarf planets to searches for free-floating black holes in the local interstellar medium, along with new observations of the faint optical and ultraviolet light of extragalactic space. Beyond that, New Horizons has already given us a wealth of data on Kuiper Belt objects that we would not have known about otherwise. Who knew that this is what Pluto would look like? That Charon has a red cap. That Arrokoth would be flat. And considering these are the only Kuiper Belt objects we've ever seen up close, there's bound to be a lot more out there that's still waiting to surprise us. Thanks for watching. If you like this New Horizons video, you should check out some of the other spacecraft videos I have made here for more of the same. Thanks to my patrons and members for supporting the channel too. If you want to help me make more videos and have your name added to this list, check the links in the description below. There's a mysterious zone far out in our solar system. It's a region of ice worlds, some solitary, some with moons. Their names may be unfamiliar, Eris, Makemake, Hormir, but they hold clues to all our origins. And the first of these worlds, and the one we'll reach in 2015, is the king of the Kuiper Belt, Pluto. The long journey of NASA's New Horizons mission began in 2006 aboard America's biggest, baddest rocket, tricked out with every conceivable booster. We built a very light spacecraft and bought a very large launch vehicle, and the combination is ferocious. But in some sense, it all began in 1930 with Clyde Tombaugh, 24 years old and fresh off a farm in Kansas, but willing to spend long hours scanning starfields to find a moving point of light, humanity's first glimpse of Pluto. The dream of actually getting to Pluto began with a 6-year-old boy in love with science who grew up to lead a team of brilliant researchers and engineers with dogged persistence through decades of planning and building and testing, a race against time just to get to the launchpad. Exploring the outer solar system, because it's so far, takes a lot of time, requires a lot of patience, a lot of dedication, a lot of perseverance, but it's a frontier. Assuming all goes well at Pluto, NASA may choose to extend the adventure further out into the Kuiper Belt, the solar system's mysterious third zone. This is maybe the one chance in my lifetime that we're going to get a spacecraft out there and look up close at one of these Kuiper Belt objects. December 6, 2014, we have New Horizons wakes up for the last time from hibernation. New Horizons is speeding towards Pluto at a phenomenal rate, and we can't wait for it to get there. January 27, 2015, 6 months of approach science begins. July 14, 2015, New Horizons long journey, 3 billion miles, 9 years in flight, and 85 years of speculation about Pluto climaxes in 1 day of close approach and flyby. You know, we're rounding third base and we're headed home. The dream, the adventure, the promise of discovery, that's what makes 2015 the year of Pluto. Studying Pluto and its neighbors from Earth is one of the toughest challenges in astronomy. It takes the largest telescopes and most advanced instrumentation on the planet, and it's tough even for the Hubble Space Telescope. And it takes time, from the discovery of Pluto in 1930 to NASA approving the New Horizons mission in 2001 to arriving at the planet in 2015. It's been 85 years, and time passing is definitely an actor in our story. But it's the combination of human skill, cutting-edge image processing, and sheer bloody-minded persistence that has resulted in the most important discoveries. And that's a tale as true today as back in 1930 when Pluto was first found by Clyde Tombaugh. 2011, at the SETI Institute near San Francisco, Mark Showalter used Hubble data to discover 2 new moons around Pluto, although he was actually looking for possible rings. Showalter has found rings associated with small moons around other planets, and that was kind of the motivation for checking out Pluto. It's got 2 little satellites. Satellites raise clouds of dust. Let's see what might be there. It's easy to take artistic license to show what Pluto's rings might look like. In reality, it's incredibly hard to see faint objects against the dense background starfield and the glare from Pluto and its large moon, Charon. We came up with this trick where you take the images and then you rotate the camera 90. You take more images, and if you do that all just right, you can do this thing where all that glare cancels out, and what we're left with is just the rings. We can think of it as a stack of images. Think of it as like a cube looking down. So let's turn it on its side. So now if we start peeling off the layers and looking downward through the stack, things suddenly become much cleaner. For example, Hydra and Nick show up very cleanly. But the thing that immediately caught my eye was this little dot right there. It's not a perfectly sharp hot pixel like over here, and that's what made it pretty convincing to me that we had seen a very small moon of Pluto that nobody had seen before. To be sure you've detected a real moon or planet, you have to show it's moving, unlike the background stars. The thing that makes moons distinctive is if we come back later, they'd all have shifted because they all orbit the central planet. This required a great deal of patience to then wait about 6 days until we got our next set of observations of the Pluto system. Sure enough, the object was still there. It had moved by just about the right amount to be something orbiting Pluto, and we knew we had a moon. Next year, Showalter and colleagues went back and built on lessons learned to see what else might be there. Summer 2012 now marked 15 more days of Hubble observations. Now what you can see here are 3 time steps. Each of those time steps is actually about 45 minutes of data. That means it's long enough that the little moons move. It's moving back and forth in the 3-frame sequence. Hydra is moving, Nix is moving. I mean, it doesn't take a rocket scientist to say that that looks like a little moon of Pluto. It's moving just the way the others are. They're all going around the planet in the same direction. And so it was just a couple of weeks later that we made the announcement that the 5th moon had been discovered. Patience, persistence, ingenuity. That was exactly what led to the discovery of Pluto back in 1930. In Kansas in the 1920s, Clyde Tombaugh grew up in hard times and built telescopes using leftover farm implements. To check the accuracy of his best telescope, he sent drawings of Mars and Jupiter to the Lowell Observatory in Flagstaff, Arizona. They were looking for staff, and he was hired. Along with observing the stars, he stoked the furnace and shoveled snow. But one assignment made history. Day after day, he'd use this machine known as a blink comparator to look for anything in his images that moved. It was tedious, painstaking work. But on plates taken on January 23rd and 29th and analyzed in February, he saw a small dot that did move against the fixed stars. Announcing the results after careful confirmation, the observatory made it easy to find the new planet by adding arrows. This is an incredible work of observational astronomy, and having done something similar, but with much more powerful tools, I can really appreciate his achievement. For decades, Pluto remained more or less a point of light. But in the mid-70s, Dale Cruikshank and colleagues attached cameras with infrared filters to a telescope at Kitt Peak. Detectors or sensors had been improved, and larger telescopes had become available. Well, we did that work in 1976 and found evidence for frozen methane on Pluto's surface. It was several years later that we found the evidence for the other ices. In 1978, astronomers Jim Christie and Bob Harrington analyzed new plates taken at the Naval Observatory in Flagstaff. Christie noted an elongation to the north of Pluto. 1 month later, the bump had disappeared. From this and other evidence, they concluded that Pluto, like Earth, had a moon, Charon. From eclipses between Pluto and Charon occurring in the 1980s, astronomers calculated that the moon was almost half the size of its parent body, so large that both objects spin around their mutual center of gravity outside Pluto. Pluto and Charon were the first double dwarf planet combo discovered in our solar system. Using the basic physics of their orbits and the distance between them, astronomers could calculate their mass and size. Pluto was a little smaller than Earth's moon, about 1,500 miles in diameter, and had only 1/10 its mass. Between 1985 and 1990, astronomers were in luck. As Pluto and Charon orbited their mutual center of gravity, each passed in turn in front of the other. The so-called mutual events allowed astronomers like Mark Bai to capture the changing patterns of light. Patiently, Bai created a map of Pluto. Pluto turned out to have one of the 2 most contrasty surfaces in the entire solar system. In the mid-90s, Bai and Allenstein used the Hubble Space Telescope to make the first direct images of Pluto's surface. And it's exciting to Mark and me and to our whole scientific team to be able to see this object that no humans really could glimpse as a real planet, as a real object in the solar system, previously. In 2005, Hall Weaver and Allenstein used the Hubble for another close look at Pluto and Charon. They discovered 2 small, dim moons where only Charon had been seen before. Now we know from Mark Showalter's work that there are 2 more moons, making the current total of 5, and that Pluto is a genuine many-planetary system. From its size and orbit, astronomers estimated that Pluto is perhaps 70 rock and 30 ice. That makes it one of the largest of a whole new class of objects, the ice dwarf planets, making up what's known as the Kuiper Belt. This region is named for Gerard Kuiper, a leading mid-20th century planetary astronomer. Kuiper suggested that the solar system didn't end with Neptune and Pluto, but that there should be a disk of other worlds beyond them. In 1992, from a mountaintop in Hawaii, David Jewett and Jane Liu found the first Kuiper Belt object. They were using new and highly sensitive kits, like the sensors in a modern digital camera. But their technique was essentially an updated version of Tombaugh's work. Take carefully registered images of a patch of sky and see if anything moves against the distant stars. This one, Bone, did just that. It was only a few hundred kilometers across, 10 times smaller than Pluto, but still huge compared to a comet. Since then, teams of astronomers have found around 2,000 kbos. Informed by cutting-edge astronomy, but with a fair dose of artistic license, let's take a trip through this third zone of our solar system. We used to think of the solar system as consisting of two different types of planets. The planets we call the terrestrial planets, which are Earth-like planets. That would be Mercury, Venus, Earth and Mars. Next out, the asteroid belt, fragments of worlds smashed to pieces by gravitation and collisions. Then come the four gas giants, Jupiter and its moons, Saturn with its magnificent rings, Uranus also ringed, and Neptune. And then Pluto was this kind of, odd guy out. It was this little object at the edge of the solar system. And then when we found all these other Kuiper belt objects, this is kind of almost a third type of object. So for the first time ever, we'll be able to fly by a brand new object, an object that's been forming for billions of years, and understand what the outer parts of the solar system are all about. By July 2015, we'll know for sure what Pluto and its moons look like. And that will provide breakthrough information on all those other ice dwarf planets, the most numerous planetary objects in the entire solar system that make up the Kuiper belt. Actually, the Kuiper belt is more like a donut, bulging up above and down below the ecliptic where most of the planets move. It's kind of like the asteroid belt, but much bigger. It has hundreds of times more objects in it than the asteroid belt. Let's now visit 5 named kbos in the exact positions they'll be in on July 14th, 2015, the day when New Horizons flies by Pluto. Quaoar was one of the first Kuiper belt objects discovered. It's about 1,000 km in diameter, a reddish world covered in water, ice, methane and ethane. And like many kbos, it has a tiny moon of its own, Quaoar. Up above and down below the plane of the solar system, numerous kbos have been flung about by Neptune's gravity. This region is known as the scattered disk. One of the largest of these kbos, Eris, is close in size to Pluto and is made of rock and methane ice. Astronomers categorize kbos by the tilt of their orbits relative to the plane of the solar system. And one of the more highly inclined orbits belongs to Make, named for a Hawaiian creation deity. Some of these have methane or water ice on their surfaces. Some of them just seem to be covered in some brownish gunk. There are grey objects out there. There are brown objects out there. They seem to be distinct populations. Some of them seem to be very spherical, and so they probably have warm interiors. And then others are peculiar shapes, which suggest they're very cold and strong. Perhaps the most bizarre and unexpected kbo is Hormi, a kbo shaped like an American football, made of rock and ice. It's white with red splotches and orbited by at least 2 moons. One of the strangest orbits of any kbo belongs to Sedna, discovered in 2003. Its orbit is the most eccentric of any kbo now known, bringing it as close as 76 or to the Sun, but then carrying it outward to 936 times the Earth-Sun distance. Sedna's strange 11,000-year orbit seems to link it to an even vaster cloud of objects ready for exploration by future generations. The Oort cloud is an immense icebox of long, Eriad comets from 10 to 100 times more distant than the Kuiper belt, surrounding all the known worlds of our solar system. The real record of the early history of the solar system out there in cold storage at the edge of the solar system. This is what was left over. Pluto is the first member of that group. But to begin humanity's exploration of the Kuiper belt, you first have to get to Pluto, and that means getting a mission approved, a spacecraft designed and built and delivered to the launch pad on time. And none of that was easy. 2015 may be the year of Pluto, but getting there has taken many long years of effort. And for New Horizons, there's a date when things got started, 1989. It was the year when George Herbert Walker Bush became president and the Berlin Wall fell. Far from Earth, it was also the year when NASA's Voyager spacecraft flew by Neptune and returned the first images of its moon, Triton. Hairstyles of some New Horizons scientists were very different. But for them, May 5th, 1989, was a most important date. That's the day that I marched into the then Division Director for Planetary Science at NASA headquarters, Jeff Briggs, as a graduate student, and asked him why we aren't studying a mission to Pluto. And he responded, "Because no one's ever asked me before." That seems like a brilliant idea. Why don't we do that? Space missions rely on hundreds, if not thousands, of people. But sometimes it takes someone with passion and persistence to make things happen. And for New Horizons, that's Alan Stern. I was interested in this when I was a boy, so I've been somewhere between in the groove and stuck in a rut for 40 years. There had been some thought about sending one of the twin Voyager spacecraft past Pluto to complete the exploration of the known solar system. But in the 70s, the scientific establishment wasn't convinced Pluto was all that interesting. Young grad students Micah Hearn, Mark Bai, and Fran Bagenal thought differently. Back in, about late 1989 or so, there was a bunch of us who were really keen to go to Pluto, and the thing that drew me to it the most was the fact that we knew so little. Here's the frontier. So it was a bit of an opportunity for young people to come in and say, hey, where are we going to go next? What's the next great frontier that we should go explore? And it was clear out to the Kuiper Belt. Alan, Fran, Mark, and a small band of enthusiasts became known as the Pluto Underground. So we realized to make this happen, we had to get together and campaign hard to make the case to go there and explore this little planet with all its moons. All through the 90s, there were many competing plans for a Pluto mission, like the Pluto Fast Flyby, the Pluto Kuiper Express. A Pluto mission was on, then off, then on, then off. If the Pluto mission had been a cat, it would have been dead long ago because they only get 9 lives and we've had significantly more than 9 stoppages and odd twists and turns. What finally turned the tide was the National Academy's Decadal Survey, a consensus document from leading planetary scientists that ranked a Kuiper Belt Pluto mission highest in priority for medium-class budgets. Finally, after competitive proposals were evaluated, New Horizons, which teamed Alan Stern with the Johns Hopkins Applied Physics Laboratory APL and several other institutions across the country, was selected by NASA on November 29, 2001. Our plans on paper became metal in clean rooms. In 2004, lead scientist Alan Stern described the mission's key science objective. Well, the key to planetary science is that you really have to go places to get the resolution to get up close enough to really see what's going on. We want to get up close and personal. The very best resolution of current telescopes looking at Pluto would give this kind of fuzzy image of a much more familiar world. But here's what New Horizons would see if flying over New York City, lakes in Central Park, wharves on the Hudson River. Your Horizons is the first, really, of a whole new breed of spacecraft that is focusing on a very specific task. For this first mission to Pluto, the questions are basic. What do Pluto and Charon look like? What are they made of? How do their atmospheres behave? We have to really be disciplined and say we can't do everything. Let's focus on the primary questions and design the instruments to answer those primary questions. The long-range reconnaissance imager LORRI will be used for navigation approaching Pluto and close views during the flyby. The wide-angle camera, RALPH, has both visible light and infrared sensors to map Pluto and Charon and characterize their icy surfaces. There are 2 fields and particles detectors to probe the solar wind at Pluto. A large radio antenna is an essential communications device. But both REX and ALICE, an ultraviolet imaging spectrometer, are part of experiments to analyze Pluto's atmosphere. And there's the Venetia Burney student dust counter, built by undergrads at Boulder and honoring the schoolgirl who named Pluto back in 1930. Together, the 7 science instruments comprise the most powerful set of detectors ever sent on a first flyby of any world in our solar system. But their innovative and highly miniaturized design means that even when all are operating, they draw less power than half a 60-watt bulb. And they're intended to work together seamlessly. After building comes testing, but always with an eye on the clock and the calendar. It's very, very important that we launch in either 2006 or 2007. We have to make that deadline. If you want to fly to Pluto on the quickest route, you need Jupiter in position, and that means we have to launch in January of 2006. It feels a little bit like being strapped to a train going 500. The test program involves teams of engineers at Johns Hopkins APL and then at NASA's Goddard Space Flight Center. Once we launch this, we can't go after it with a screwdriver. We can't go fix anything that isn't working. We make sure that we carry plenty of spare equipment on board the spacecraft. If our main computer breaks, we have a backup. If our main transmitter breaks, we have a backup. One of the things we do is we put the whole spacecraft on a gigantic vibration table, a paint shaker, and shake it, and then test it after that, and shake it again and test it again. So that's what we're doing from now until launch. Along with testing the spacecraft, New Horizons needs to train and test its human operators. And for a mission planned to reach Pluto in 2015, it's important to have young people on board early so they'll be around at close approach. It's good that we can do that so they will have both the time and the focus to stay with the mission over this long period of time. Many of the faces you see around Mission Control in 2004 and 2005 are young and enthusiastic spacecraft engineers. Normally, we're focused on subsystems and instruments in the spacecraft surviving that duration. But, for people, we have to have a longevity plan. They'd be committing the prime of their careers to this mission to Pluto, knowing they'd be a decade older when New Horizons reaches its primary target. The ability to practice things in those years far out there are all part of the planning now to assure mission success then. How old are you going to be in 2015? I don't know, something somewhere in my 40s. Oh, you're a youngster. Yeah. In late 2005, the action shifts to Cape Canaveral. New Horizons may be light and relatively small, but launching it to Pluto requires America's most powerful rocket, the Atlas, the FE. New Horizons will be traveling so far from the sun that solar panels wouldn't be sufficient. So the Department of Energy delivered an REC that would power the Pluto mission by turning heat from the radioactive decay of plutonium into electricity. Working around the clock, they arrive at Pad 41 before dawn. On behalf of NASA and the entire New Horizons team, Stern wanted to be the last to bid the spacecraft bon voyage before closing up the hatch. On January 19, 2006, after 17 years of planning, building and testing, a picture-perfect launch that thrilled onlookers in Florida and the mission operations team back at Johns Hopkins in Maryland. We have Horizon. We visit Pluto and then beyond. Despite immense technical and timetable challenges, the mission had made its window and was on its way. New Horizons' velocity at launch was the fastest ever, traveling almost 60 times faster than a jetliner. In just 9 hours, it passed the orbit of the Moon. Apollo had taken almost 10 times that long. 1 year later, a slingshot gravity assist from the giant planet Jupiter provided another 2-second boost, cutting travel time to Pluto by 3 full years. But this was more than just a jump in speed. The Jupiter flyby was a scientific dress rehearsal for Pluto. New Horizons instruments returned detailed images of Jupiter's clouds, moons, and we got the night. Whoa, look at that. Then it was off across the empty ocean of space with no new land in sight till Pluto in 2015. The spacecraft had been tested and passed with flying colors. Now, it was time to test the humans and the ground systems. July 5th, 2013. It's day 1 of a 9-day encounter rehearsal. The main success criteria for this rehearsal is for the spacecraft to flawlessly perform its activities as if it were at Pluto, with everything the same except the Pluto is not there. The dates in 2013 were carefully chosen so that Earth received times would be identical to those for the real encounter in 2015. Mission managers wanted scientists and engineers to experience the stress of time-critical, 24/7 operations expected for July 2015. We're flying by an object that is a huge distance from Earth, and we're trying to hit a box that's 100 by 150 wide, and that then leads into maneuver planning and trajectory control needed to thread that needle and hit that small box. It's way the heck out there. This rehearsal would actually be uploading commands to New Horizons to instruct the spacecraft to run through the exact same set of observations as in 2015. Definitely is an element of risk involved. But from one standpoint, if you didn't do any simulation with the real spacecraft at all, you could argue that could pose more risk because you don't want such a critical activity only being done once on flight. Those are all invaluable to get us ready and practiced for the one and only shot we'll have to explore the Pluto system. We've been waiting 12 years since we wrote the proposals to do this rehearsal. It's the last big step before we can do the encounter. We think that we are about 10 million miles out from Pluto and closing, but so far, so good. We're off to the races. Today is our 2,724th day in flight. This has been a long time coming, literally. I only want to say thanks for all the work. Let them eat cake. July 12, 2013, standing in for July 14, 2015. This is it, a minute, in-it simulation of Encounter Day. It's make or break. Well, it's the most important because we've been spending the 24 hours of the most intense activities that we've been running on the spacecraft, and this is the longest that we've been out of contact since we've entered encounter rehearsal. This may be a rehearsal, but New Horizons has been firing its thrusters and spinning in space, identical maneuvers to those planned for 2015. On Encounter Day, the spacecraft will be too busy taking data to send back images. That's why its first simple "I'm alive" message will be so important. Sometime within the next minute, S-43 should lock up on the signal. We're good. We're nominal. The spacecraft's nominal, and it looks like all the observations that planned between last track and this track happened. This gives us good confidence that at least the spacecraft has been performing all of those twists and turns that we've been anticipating it to over the last 7 days. I like to say that at the flyby, I don't want to be learning anything about the ground system or the spacecraft or the team. I want to be learning only about the Pluto system. No spacecraft has ever been to Pluto, nor will ever go back in our lifetime. Pluto is every child's favorite planet. You know, you ask anyone under the age of 6, they're going to say Pluto. We don't exactly know what Pluto looks like, but it looks very exciting from the images we have from the Hubble Space Telescope so far. We really can't wait to get there and see what it actually looks like. So if anybody says that Pluto is boring or not important, no way. Before New Horizons arrives at Pluto, most everything we think we know about the planet and its moons is up for grabs. Virtually every place we've sent a spacecraft on a first reconnaissance mission like this, we find out that our Earth-based notions were flat wrong. So I'll tell you what we expect, but before anything, what we expect is to be surprised. From the 1990s through today, Stern has been consistent in avoiding speculation. You get the same answer everybody's gotten from me for almost 20 years. I don't make predictions, except for one. My best guess is we're going to find something wonderful. But in the final months leading up to the July 2015 encounter, it's hard for most humans not to imagine what we'll see. Many planetary scientists, like Paul Schenck, base their expectations on what we saw when Voyager 2 reached Neptune and specifically as it flew by its moon, Triton. Voyager was a 10-year-long exploration of the outer solar system, and every time they got to a planet, it was basically the first time anybody had really seen those bodies. So when they got to Jupiter, they were greeted with enormous surprises. The erupting volcanoes on Io were just completely unexpected. And so when they got to Uranus, there were more surprises. The exotic terrains of Miranda and Ariel, for example, were not expected. So by the time they got to Neptune, they were kind of accustomed to the idea that they were going to be surprised. And sure enough, Triton completely blew them away. Bonnie Birati was at NASA's Jet Propulsion Lab as the first images of Triton, a moon of nearly 1,700 miles in diameter, came down. Triton was almost a twin of Pluto. It's about the same size, about the same brightness. Originally, Triton was probably a Kuiper Belt object just like Pluto, floating around in space. But then it got too close to Neptune, and it got captured by Neptune's gravitational field. Recently, Paul Schenck enhanced the original Voyager data to create this detailed flyover of Triton. It has odd patches and odd blob-like features, kind of like amobas crawling around on the surface. Triton has very few impact craters. Its surface is extremely young geologically, and it actually has geysers spouting material off into space. Here is a body that is hundreds of degrees below zero, so cold, it's forlorn, it's barren. We just didn't expect to see this activity on Triton. It was quite a surprise. If you just assume that Pluto was going to look exactly like Triton, which is the most similar object we know about, then you might expect to find a very interesting body. Triton is not the only dynamic ice world in the outer solar system. 16 years later, the Cassini spacecraft sent back images of Saturn's moon Enceladus, about 300 miles across. This is a tiny little moon, and Enceladus is actually a winter wonderland. It's very bright, it reflects almost all the radiation that falls on it, and it has these huge ice volcanoes spewing out from its south pole. And Enceladus is continuously giving off puffs of water vapor. And so if you start to see puffs of water vapor coming off Pluto as New Horizons gets closer, that would be exceedingly interesting. But what forces can power volcanoes in the deep freeze of the outer solar system? Triton and Pluto are both balls of ice with presumably rock in the center. And so one of the sources of energy is radioactive decay inside the rock, which gives off heat just like the Earth is heated. If you just let Pluto sit there and pump the heat out of the rocks, you generate enough energy to melt a couple of 100 kilometers worth of ice. It's still possible to have an ocean beneath a relatively thick ice shell. The ice shell might be 100 miles thick or so. Over billions of years, the ice shell gets thicker and thicker and thicker as Pluto cools. And as it does so, it squeezes the water underneath. And if you squeeze the water too much, then it may well actually create fractures, and the water could jet out to the surface. You're going out to the edge of the solar system. You kind of have to expect some surprises. And we're going to see them at Pluto as well. Just as Triton and Enceladus were mere dots before spacecraft reached them, until now, Pluto has been an astronomer's planet. That's about to change. We are going to start off as astronomers, and we'll be using astronomical tools to try and sharpen up our images and pull every last little bit of detail out of these fuzzy blobs. We gradually turn from astronomers into geologists as we get closer, and it becomes a real world. Jeff Moore was in the room at Chapel as those Triton images came down, but he also enjoys field work and thinks we'll recognize some similar planetary processes at work on Pluto as back on Earth. So I'm a geologist, and although we don't expect to see oceans on Pluto, there are common processes which operate on this planet which are likely to operate also on Pluto and its moons. While the scales are very different, erosion shapes landforms here on Earth and all across the solar system. There are these little finger-like projections that are formed by the process of erosion where wind and water have sculpted this landscape by taking advantage of small differences in the strength of the original rock, creating large, huge, fantastic landscapes such as on Jupiter's moon Callisto. And we can anticipate that we may perhaps also see landscapes like this on Pluto and its moons. Pluto's 48-year orbit is more eccentric than our solar system's terrestrial and gas giant planets, greatly varying its distance to the Sun. It's typical of many other objects in the Kuiper belt and newly discovered planets around other stars. That, plus its highly angled polar tilt, combine to produce strong seasonal effects. In fact, the seasons of Pluto are amongst the most extreme of any seasons on any world that we know of orbiting the Sun. And those extremes may be one reason why its surface is also extremely contrasty. Pluto is perhaps the most intensely bright and dark place that we've seen in the solar system. This dark surface collects more heat. It warms up like asphalt does on a sunny day here on the Earth. And if there were frosts that had settled on this dark surface, they're being heated up and driven off. And the transportation of this material could also be creating wind. So you might see small dunes oriented along the periphery of the dark surface, showing this process in action. For planetary scientists, color can be a clue to the composition of surfaces that can't be sampled directly. On the Earth, these kinds of colors from red to dark gray are generated entirely by the presence or absence of rust. On Pluto, we see also these same ranges of colors from gray to bright, white to yellow to red to black. But there it must be due to a completely different process. At NASA's Ames Research Center near San Francisco, longtime Pluto researcher Dale Cruikshank and postdoc Chris Mehta conduct experiments to see what processes might create the colors we see on Pluto, starting with gases like methane and nitrogen and the extreme low temperatures we know are found there. In our cold chamber, we can produce a thin film of ice and then after that, expose them to a beam of electrons, which are charged particles comparable to what comes into Pluto's surface from space. We find that when we shine ultraviolet light or electrons on simple molecules, before too long the simple molecules are broken apart and by natural processes, they reassemble into more complex chemicals. So far, the colors we make in the lab from irradiating these ices is fairly close to what we see on Pluto. There are tones of yellow, light brown, up through fairly dark red. And if we carry the processing by ultraviolet light to an extreme degree, the material actually turns black. And this is almost the color of pure carbon. Seeing how radiation transforms simple ices into complex and colorful organic molecules should help interpret the close views of Pluto's surface that will be sent back by New Horizons. Color translates to the duration of the exposure of these otherwise colorless ices over a year, 10,000 years, 10 million years. That may in turn tell us more about the nature of the exposure of Pluto's surface and even the age of Pluto's surface. Dale Cruikshank began observing Pluto back in 1976. Now, 39 years later, he's ready for its close-up. We can say that Pluto is chemically active, chemically dynamic. We don't know yet if it's geologically active and dynamic, but that's what New Horizons is going to tell us. We've been surprised in that way before as we've passed other planetary bodies that we had thought were totally cold, dead, inert worlds and find that there are geysers, there are ice flows, there are cracks and all kinds of evidence for geological activity. I can still remember the first time I saw Pluto in a telescope, and it was just a little dot that you could barely see. It will be amazing that within a period of hours, it will be transformed from this tiny dot that I studied as an astronomer to this huge geologic world that will be able to see volcanoes and faults and ices and mountains and craters. I mean, it will be truly an amazing experience to see it transformed. So from sophisticated lab experiments, from exploring other worlds and from applying insights from terrestrial processes, what should we expect when we get to Pluto in July 2015? In fact, the only thing that would surprise me would be if we turned out not to be surprised. But enjoying the scientific surprises to come means avoiding dangers on the last few million miles to Pluto. That's next. December 6, 2014, in Mission Control, Alice Baumann and her team wait to get confirmation that New Horizons has exited what's called hibernation. For 2/3 of its 3 billion-mile journey, most spacecraft systems have been turned off, saving wear and tear on the science instruments. New Horizons sends a simple signal once a week just to say, "I'm still a hook." Alice's team has a unique way of showing spacecraft status. When New Horizons is hibernating, their bear mascot is safely asleep. When the spacecraft wakes up, they put on its party hat. If all goes well, this will be the 18th time spacecraft and bear have woken up. December 2014 is different. VIPs from NASA are on hand. 2 film crews document the action. As Alan explains the benefits of hibernation, it lowers our costs because we don't need to have people babysitting the spacecraft 24/7. Outside interest in New Horizons is building. If all goes well, New Horizons will stay awake, flying by Pluto in July 2015 and then returning data until October 2016. Copy that. Thank you. Chinch. Tonight, data trickles in, and Alice has to wait to be certain New Horizons is fully awake. We should be getting it momentarily. Should be any minute now. This is like watching paint dry. I figure if I stare at the screen hard enough. And packet 5 just came in. There we go. Oh, I'm on Pluto 1. We have a nominal wake-up of the New Horizons spacecraft on its way to Pluto, ready for our next leg of the journey. He's awake. Our bear. He's going to be here for a while. This is a red-letter day. We have completed the cruise across 3 billion miles of space. The spacecraft is now awake. Finally, after 9 years, I'm glad to see hibernation behind us and active ops ahead. Onto Pluto. But there are still hundreds of tasks to ensure a safe flyby in July 2015. January 27th, New Horizons has been sending back technical data, and all seems fine. But today is the first time Hall Weaver and Annie Cheng will be seeing new science images. Thought I saw it pop up here. Let's try that again. Cheng is lead scientist for the LORRI camera. LORRI is used for navigation to find the targets and to correct the trajectory so we get to the right place at the right time. Voltages, currents, temperatures all look normal. No error messages. This is it. Let's check out the very first images. And then Karen right there. 8 pixel 55. There key. All right. So there they are. Let's look at the whole. For Project Scientist Hall Weaver, even the jump in size from 1 to 2 pixels was significant. This is a real milestone in the New Horizons mission. The very first images of Pluto in the Pluto Encounter year. Hadn't turned LORRI on, hadn't gotten any images since last summer, last July. But this is it. This is the start of it. Our she, Lu. We really don't know what we're going to see. That's what this mission is all about. What is the surface of Pluto really like? How big is it? What are the orbits really? So it's nothing but delightful surprises coming for us. But some of the surprises may not be quite so welcome. As New Horizons get still closer to the Pluto system, LORRI will be able to identify small moons and possible rings that can't be seen from Earth. John Spencer is leading the EARS campaign. EARS stands for Unknown Hazards. We may find new moons, or even rings around Pluto. And if we see anything like that, we're going to want to determine whether it poses a threat to the spacecraft. Because if it does, if there's debris that we might run into that might damage or kill the spacecraft, then we want to evaluate that hazard and determine whether we should take any evasive action. To find out just how vulnerable New Horizons might be to even tiny dust particles, the mission sent samples of spacecraft components to the White Sands test range. Technicians at White Sands set up gun tests to assess how vulnerable New Horizons' outer covers and cables might be. We went to 2 facilities that could shoot things into parts of models of the spacecraft. While the results might look dangerous, the mission has options to take evasive action. One of the backup strategies we have if we feel we need to give the spacecraft extra protection is that we orient it so that the high-gain antenna here, which is literally pretty bulletproof and can protect the spacecraft, is going to be facing forward in the ram direction. And this is ram in the sense of battering ram. It's a direction in which stuff will be coming at us and ramming into the spacecraft. If that is facing forward, then any dust particles that hit the spacecraft are most likely to hit that antenna, where they won't cause us problems, and only a small part of the spacecraft around the edges is going to be exposed to those particles. That would protect the guts of the spacecraft, but limit the pointing of the cameras. The cameras are fixed to the spacecraft. So if the spacecraft has to point in one direction, the cameras can only point in a limited range of directions. This limits the amount of times we can photograph the system as we go past, because we can only photograph objects when they're just in the right angle that we can look at them while protecting the spacecraft with the main antenna. Another option is to take different trajectories through the Pluto system. That's called the Shabot play. Shabot is the best acronym in the space business. It stands for Safe Haven by Other Trajectory, and it is the word we use to represent our backup plans at Pluto. The second Shabot takes us much closer to Pluto, into the region where atmospheric drag depletes orbits of any debris, which we think would be the safest Hail Mary pass that we could fly if we have to do something different than the nominal. We are coming into the Pluto system with the ability, if we learn something we don't expect, to be able to make a change and get the goods. But those decisions can only be made in the last month before closest approach, and there'll be limited time to evaluate the best options. So in February 2015, Spencer's team, including Ring specialist Mark Showalter and postdoc Simon Porter, are running through a readiness test. Now they're on the clock and being scored for whether they can work through the calculations fast enough to decide on a trajectory correction maneuver that might prevent loss of mission. And that makes this exercise more critical than any that have gone before. The difference between this and previous operational readiness tests is that this is where we have to demonstrate to the project of NASA that we can do this. But the only test that really matters comes on July 14th, 2015. That one day will pay off 26 years of dreams and 9 years in flight. For the science team, the year of Pluto began with another meeting to review the latest data on the Pluto system and to hear updates on how the spacecraft was performing. Mission manager Glenn Fountain, who'd been with the project from its start, summarized remaining risks. Red boxes are possibilities that could kill the mission. But now in 2015, there are more and more green boxes, risks that have been minimized. Something that we haven't thought of still might happen. But I'm confident that whatever happens, whatever fate throws at us, this team will be able to resolve it, and we'll go on to get wonderful data when we get to Pluto. We have a fantastically talented team of people who have worked very hard, and we've tested the sequences inside and out. And while there are always unknown unknowns, I'm very confident and really looking forward to the curtain rising. Along with mind-ending technical details, there also was a sense of history in the making. To document the long years of effort to get this close to Pluto, the mission recreated a team photograph taken in 2004. As Glenn, Alan, and Elise had carefully planned back then, many of the scientists and engineers were still actively engaged in New Horizons and looking forward to July 2015. We have worked hard to get a coherent team, because if you don't have a good team to operate the spacecraft to do the planning, you will fail. And so we worked to plan early in the mission to have younger people with the right amount of experience to be on the mission. And it's just like watching your kids grow. It's like all of a sudden, where did the time go? You know, they are older, they're more mature, and they're now the very experienced veterans. But the hard work of mission planning was by no means over, even this close to encounter day. While exploring Pluto in 2015 is exciting in itself, New Horizons was recommended in part as a mission that might continue on farther out into the Kuiper Belt. That takes identifying potential targets now for a still more distant flyby, should NASA approve an extended mission. This challenging task was assigned to John Spencer, Mark Bai, and a team of young postdocs. And like everything else about this mission, it wasn't easy. Bai and John Spencer had been using Earth's largest telescopes in Hawaii and Chile, but even Earth's best couldn't crack this task. The basic problem is the Earth's atmosphere is just a mess at these scales. There's a limit, and that's what we've been beating our heads against. Now, with time running out, we had to turn to Hubble. And so we sort of not so okingly talk about Hubble to the rescue. Without Hubble, we would not have these objects. Mark and his young collaborators came up with innovative search techniques using custom software. What that does is makes the stars smear out and makes the Kuiper Belt objects hold still. It's been a lot of work, but to do something as exciting as this has been just so much fun. I've been plugging through the data today because it's fresh data and I just really really wanted to know what the answer was, well, we would have been in big trouble if we didn't find the Kbo in time. So, there was this pressure. But honestly, we had the best people in the world working on the problem, and we did it. And we just do the math, write the software, crunch the pixels, and then I create this graphic. From that point on, it's what I call wetware. It's what you got in your head. In reality, Kbos are moving against the fixed stars. Mark came up with a way of making them more obvious by flipping that around and making the stars appear to move and any Kbos stand still. Right in the middle, there's something that's just holding dead constant, and that's the Kuiper belt option. You can't argue with that. It was a high-tech variant of the approach that had been instrumental in exploring the Pluto system right from the start. But at the core, it's a technique that hasn't really changed since Tumborf's day. You have two pictures of the sky taken at different times, and you're looking for the stuff that moves. As soon as you see something real, there is absolutely no question about it. As soon as it flashes on the screen, in just a millisecond, there it is. It's real. And you found another Kuiper belt object. Finding a Kbo is only half the battle. Is it located where New Horizons can reach it with available fuel? Once you have the orbit, then we know where the spacecraft is and where it's going to be. We can figure out how much fuel the spacecraft is going to need to use to get to these objects. With more Hubble time, New Horizons got a pleasant surprise. It looked like we might actually have to burn the engines to miss the object, which was a pretty exciting concept. It's a good thing we looked, because you wouldn't want to run into one of these things. These cold classicals, they're pretty much as they were 4.5 billion years ago. They're little fossils. That's incredible. We have no idea what they're going to look like. So with potential targets found at last, it was on to Pluto. I'm feeling pretty exhilarated at this point. You're at the top of the roller coaster. You are about to go down that dizzying, thrilling ride into the system. Just seeing Pluto there getting bigger and bigger, it gives me goosebumps. Today, we're only a few months away from the encounter. We're less than an astronomical unit, the distance between the Earth and the Sun, that distance away from this fascinating object. It's the last major body in our solar system that we really need to visit to be putting the capstone on the initial reconnaissance of the solar system. It's heartwarming, and it feels like something that makes a career worthwhile. As spacecraft go, New Horizons is a very small team, but still, we've been working on this for over a decade. And you add it all up, and it's about 2.5 million work hours to get ourselves to Pluto. We have waited first the 4 years that we couldn't hardly think about because we were running so fast, and then it is, we wait, and now we are ready to begin the encounter. We have had delayed gratification. The year of Pluto is, simultaneously a beginning and an ending. It's an ending in that we are completing our objective. We're accomplishing the flyby of the Pluto system for the first time. But it's also the beginning of a whole new chapter for science, of really being able to explore these objects as the data comes down over a period of months. In bringing in postdocs and the younger scientists, who some of them were in high school when we started this project, and now they have their FEDs and they are spectacular experts and very talented at what they do. I was in preschool when Alan first started talking about a Pluto mission, and finishing high school and starting college when it was built, and in grad school for the crews. Having young people come into these programs, gaining the experience, they're going to be the next generation of explorers. We've never been to a Kbo. We've never been anywhere close to a Kbo. It is the most unexplored area of the entire solar system, which is in another way of saying, this is the most unknown area that we as humans can reach with spacecraft. We can't wait to get to Pluto and to July 14th and see what the surface looks like. We're ready to go, and it's showtime. We are capable of continuing an adventure that humanity began 100,000 years ago as our ancestors walked out of Africa. And we are continuing that exploration, and this country is in the forefront of doing that. What if I told you the last clear images we'll ever get of Pluto reveal a frozen heart that might still be beating, a moon painted red by its parent planet, and a strange, untouched object deeper in space than anything we've ever seen? This is the story of New Horizons, a mission that shattered what we thought we knew about the edge of our solar system and may have uncovered clues to something far more ancient and possibly not so natural. It started with a blur, a distant dot, cold and forgotten at the edge of the solar system. For decades, Pluto was little more than a mystery, a smudge of light in our telescopes, dismissed as a frozen rock too far away to care about. But in 2006, NASA launched something special, a small spacecraft called New Horizons, racing faster than anything humanity had ever sent into space. Its mission: reach Pluto before anyone else and reveal what no one had ever seen. And when it got there 9 years later, what it found was breathtaking: a giant icy heart carved into the surface, towering mountains made of solid water, and an atmosphere that shouldn't even exist. But the story didn't end there, because New Horizons kept going, deeper, farther, until it encountered something even stranger, a silent relic from the birth of the solar system. For most of modern astronomy, Pluto was a cosmic afterthought, too small, too far, too dark. It was discovered in 1930 and then quietly ignored by science for decades. Some textbooks barely gave it a paragraph, others didn't even bother with a photo, because we didn't have one. From Earth, all we could see was a blurry dot. Even the mighty Hubble Space Telescope couldn't do better than a few colored smudges. Then came 2006. As debates raged about whether Pluto should even be considered a planet, NASA launched New Horizons, a lightweight spacecraft no larger than a baby grand piano but with the fastest launch speed in human history. How fast? It passed the moon in just 9 hours. That's 10 times faster than Apollo. But this wasn't just a race. This was a mission of redemption, a chance to finally take a closer look at the last unexplored world from our original 9 planets. Why Pluto? Because Pluto sits at the gateway to the Kuiper Belt, a mysterious region beyond Neptune filled with icy bodies and cosmic leftovers from the early days of the solar system. Scientists believe that if we could see Pluto up close, we might unlock secrets about how planets form, how our solar system evolved, and maybe even find clues to what else is hiding out there in the dark. But no one really expected Pluto to be beautiful. Most thought it would be a dull, cratered ice ball. What New Horizons found instead changed everything. And as the spacecraft drifted closer, slowly, pixel by pixel, Pluto began to reveal itself, not a rock, but a world. Coming up, the first images that stunned scientists and the mysterious shape that made headlines around the globe. After more than 9 years of silent travel through the void, New Horizons finally approached its target, and almost instantly, the mission began to feel different. Every day, the spacecraft sent back a few more pixels, a little more detail, like a photograph slowly developing in the darkroom of deep space. The data was slow, just 1 kilobit per second, but what it revealed was worth every second. As the blurry dot of Pluto grew into a discernible sphere, the world began to show its face. Shadows moved across cratered ridges, hints of ice reflected light from a distant sun, and then something appeared, a giant, light-colored shape across Pluto's surface, unexpected, symmetrical, and unmistakably heart-shaped. It was a poetic twist the universe didn't have to give us, but it did. Later named Sputnik Planitia, the heart of Pluto became the symbol of the mission. But beneath its beauty, scientists saw something more. This wasn't a static world, it was alive. There were shifting ices, smooth plains, even evidence of recent geological activity. Pluto wasn't some ancient relic frozen in time. It was dynamic and hiding secrets far more complex than anyone had dared to imagine. The excitement grew with every image. Public followed the mission like a global countdown, and on July 14, 2015, New Horizons reached its closest point, just 12,500 km above Pluto's surface. But at that moment, the spacecraft went silent, not because it failed, but because it was too busy taking hundreds of high-priority photos to transmit anything back. All we could do was wait. Hours passed, then days, and when the first full-resolution images finally arrived on Earth, they revealed something no one was prepared for: towering ice mountains, glacial flows, strange chemical compounds, and a planet that just might be reshaping itself from the inside out. Now, we will uncover what New Horizons discovered during its historic flyby and why Pluto may be one of the most mysterious objects in the entire solar system. When the first detailed images of Pluto arrived, scientists didn't just gasp, some of them cried. What they saw wasn't a dead rock. It was a living world sculpted by forces no one expected to find 7.5 billion from the sun. At its core lay Sputnik Planitia, the giant icy heart seen from space. But this wasn't just a pretty landmark. It was a massive glacier the size of Texas made almost entirely of nitrogen ice. On Earth, nitrogen is a gas. On Pluto, it flows like water. Scientists noticed something strange about the ice plains. No craters. That meant they were geologically young, possibly less than 10 million years old. Surface showed signs of convection cells, polygon-shaped patterns caused by slow, churning flows of ice rising and falling like a cosmic stew. Surrounding these plains were towering mountains as high as the Rockies. But these were not made of rock. They were made of solid water ice, so cold and strong it behaves like granite. And nestled among these icy peaks were structures that looked suspiciously like volcanoes. But they didn't spew lava. They erupted with ammonia and water, possibly even organic materials. These were cryovolcanoes, ice volcanoes, and Pluto had more than one. One of them, Right Mons, stood 4 km tall and had a deep central pit. It looked quiet, but far from dead. Across the surface, there were dark scars, regions like thulomacula covered in reddish-black material. The source? A strange compound called tholins, formed when ultraviolet light hits simple molecules like methane and nitrogen. These tholins may sound alien, and they kind of are. They're complex, sticky, and prebiotic, the same stuff that could exist on the early Earth. But Pluto wasn't just hiding secrets on its surface. New Horizons detected a tenuous but real atmosphere made of nitrogen, methane, and carbon monoxide. Unlike Earth's dense air, Pluto's atmosphere extends high above the surface, with up to 20 separate haze layers like ghostly curtains suspended in the void. These hazes refract sunlight in eerie ways. In one photo, mountains cast shadows through blue mist, like something from a dream. Even more bizarre, Pluto's atmosphere changes with the seasons. It can expand or collapse entirely depending on how close Pluto is to the Sun in its elongated orbit. In fact, the pressure on Pluto can increase 4-fold in just one Earth year. And deep in one region, scientists even spotted what looked like a frozen lake. Not water, liquid nitrogen. It's a world that shouldn't be alive, but somehow it is. And yet, even that wasn't the strangest part, because just beyond Pluto's mountains and ice plains, another world was quietly watching, a world so closely bound to Pluto they orbit one another like a pair of locked dancers, forever facing each other. But this moon was hiding a secret of its own, a red stain, a cosmic fingerprint left behind by Pluto itself. Just above Pluto, orbiting so closely it almost touches it, is a moon unlike any other, Charon. It's so massive relative to Pluto that they don't orbit like a normal planet and moon. Instead, they both circle around a shared center of gravity that lies in the space between them. They are tidally locked, eternally facing one another, a gravitational standoff frozen in time. Here is where things get strange. As New Horizons approached, it captured something unexpected, a deep red cap smeared across Charon's north pole. It was haunting, alien, and beautiful. But what could paint a moon like this? Scientists believe the answer comes from Pluto itself. You see, Pluto's thin atmosphere is constantly leaking into space, and thanks to its weak gravity, some of those organic particles, tholins, escape entirely. Like a whisper on the wind, they drift through the darkness and fall gently onto Charon. Over time, these particles settle at the poles, where temperatures are cold enough to trap them permanently. Charon's red cap is a gift from Pluto, a cosmic tattoo that marks their bond. Two bodies locked in orbit, exchanging matter, shaping one another's identities. While Pluto hides its frozen heart, it leaves a mark on the one world that always sees it, a poetic symmetry. But Pluto and Charon were only the beginning, because beyond them, far deeper into the Kuiper Belt, New Horizons had one last stop to make. No one had ever seen it before. It was too small, too far, too dark. But just before reaching Pluto, astronomers pointed the Hubble Space Telescope into the abyss and found something waiting, a strange, untouched object shaped like a snowman and possibly older than any world we've ever visited. Just when it seemed the mission had given us all it could, New Horizons kept going. But this time, it wasn't heading toward a known destination. It was diving into uncharted space, a region so remote no spacecraft had ever been there before. Months before reaching Pluto, astronomers pointed the Hubble Space Telescope into the void, hoping to find a second target. What they found was a faint, distant speck, something barely visible even to Hubble, a body later named Arrokoth. It was so small, so remote that we discovered it after launching the spacecraft that would visit it. That alone was a first in human history. Arrokoth lies over 6.5 billion from the Sun, drifting through the cold and quiet Kuiper Belt like a message in a bottle. It took another 3.5 years after Pluto for New Horizons to catch up, and when it did, on January 1st, 2019, the first images trickled back and the world was stunned. Arrokoth didn't look like an asteroid. It didn't look like a comet. It looked like a snowman. Two distinct lobes fused together in a shape known as a contact binary, something rarely seen up close. But more than its shape, it was the absence of violence that told a deeper story. Arrokoth had almost no impact craters. Its surface was smooth, undisturbed, and eerily quiet. Unlike the scarred worlds of the inner solar system, this object had been preserved, untouched, for over 4 billion years. It's not just a rock. Arrokoth is a time capsule, a frozen snapshot of the solar system before the planets even formed. Its reddish color comes from tholins again, those complex organics altered by radiation. But its chemistry held surprises. New Horizons detected methanol, water ice, hydrogen cyanide, and one mystery compound that no one has yet identified. Something on Arrokoth absorbs light at a very specific wavelength, 1.8 microns, but nothing we've catalogued matches it. We may have discovered a substance never seen anywhere else. Even its temperature was a surprise. Models predicted Arrokoth should be around 12 to 14 Kelvin, but it was almost 30. Something deep inside may still be giving off heat. And then, there's its shape. From a distance, Arrokoth seemed symmetrical, but as scientists studied the data, they realized it was fatter than expected, not a round snowman, more like a pressed one. Some believe this flattening could be from centuries of sunlight heating only one side at a time, releasing gases and reshaping the body slowly over millennia. Or maybe it formed this way, two fragile bodies orbiting each other, spiraling inward until they touched and stayed that way forever. The collision was likely slower than a walking pace, just tombs. And that's what makes Arrokoth so important. It didn't crash into other bodies. It didn't shatter. It survived, perfectly frozen in time since the birth of everything we know. And maybe, just maybe, it still holds answers we haven't learned to ask yet. New Horizons captured one last image of Arrokoth as it drifted away, a pale silhouette against the stars. It may be the last time any human-built object will ever see it. But the journey isn't over, because out there, beyond even this ancient relic, New Horizons continues to fly. As New Horizons drifted beyond Arrokoth, it turned one last time to look back. And what it captured was silent, a dark silhouette suspended against a sea of stars. There was no celebration, no roar of engines, no countdown, just the quiet hum of a machine 6.6 billion from home, whispering back the final images we may ever see of these distant worlds. And yet, something about that silence felt complete. Pluto, not just a frozen rock, but a world with glaciers that flow, volcanoes that erupt ice, and a heart that seems to beat beneath the surface. Charon, a companion moon marked by the breath of its planet. Arrokoth, a cosmic time capsule older than Earth, untouched by violence, holding secrets from before the planets were born. New Horizons didn't just take pictures. It changed our understanding of what's possible at the edge of the solar system. And it's not done yet. The spacecraft still has fuel in its tank. Its instruments are alive. Now NASA wants to give it a new mission, to turn New Horizons into the most distant observatory ever built. It could study ultraviolet light from distant galaxies, detect rogue planets, maybe even help us understand the true shape of the heliosphere that surrounds our solar system. Think about that, a tiny probe launched in 2006, flying silently through interstellar space, still sending us data, still rewriting the books. And somewhere out there, beyond where even sunlight begins to fade, New Horizons is watching, waiting, listening, ready for whatever comes next. If these distant worlds gave us this much wonder, imagine what's hiding in the galaxies beyond. The James Webb Telescope may have already found something that changes everything. Watch this next video and discover the possible alien signal that has astronomers holding their breath. In 2015, there was a huge excitement in the space community. That is because up until then, the best image we had of the Pluto system was this. Hubble also squinted its lens at Pluto, but it is so small and distant, the best it could see was a few blobs of Kalauer variation. But in 2015, this all changed. That is because after a 9-year journey, the New Horizons space probe flew by the dwarf planet, giving us a detail and fidelity of Pluto and its moons like we had never seen before. So the question is, what did the New Horizons probe see and discover during its flyby of the Pluto system? I'm Alex Kulgan, and you're watching Astrom. Stick with me in this video and I will show you all the highlights from the New Horizons mission to Pluto. Pluto was the last of the traditional 9 planets to be explored. This was due to its distance from us. but also because, can you believe this, it wasn't considered a very interesting celestial object. Thankfully, the New Horizons team pushed hard for this mission to be approved, and in 2006, New Horizons launched as part of NASA's New Frontiers program for medium-budget space missions. The goal of the mission was to get to Pluto as soon as possible, and as such, New Horizons was the fastest launch ever, it being a light spacecraft on the most powerful rocket of the time, the Atlas V. It whizzed past the moon in only 9 hours. The Apollo missions took 10 times as long. On its way to Pluto, it used Jupiter as a gravity assist, which shaved 3 years off the arrival time. It also used Jupiter as a trial run for its systems, taking some remarkable videos and images of the planet and its moons. After this successful trial, New Horizons went into hibernation mode to prevent wear and tear of its instruments. Leading up to its approach in 2015, the team turned the systems back online, and every day the spacecraft sent back images of the Pluto system. This was an incredibly exciting time for enthusiasts following the story. We began to get hints of what Pluto could possibly look like, and saw how different Pluto was from its biggest moon, Charon. Every day, the resolution got higher and higher, and more details could be made out. Yes, there were other scientific goals for the mission, but the most interesting thing to me was what it looked like. Soon there could be seen what looked to be a heart shape on the dwarf planet. On the 14th of July, the New Horizons probe made its closest approach, at only 12,500 from the surface of Pluto. However, mission controllers didn't get a look straight away. Firstly, the probe was too busy taking a lot of photos during the flyby to send any back immediately. Once data transfer commenced, they had to deal with the slow uplink speed of only 1 bitsec. Further to that, there was a 4.5-hour latency between the spacecraft and the Earth. But what it saw and sent back was spectacular: mountain ranges, ice plains, glaciers, and an atmosphere. It also had a good look at some of Pluto's moons. Let's go into detail about what it actually discovered during this flyby. One of the first things observed about the Pluto is its unusual relationship with its moons. For a start, Pluto's biggest moon, Charon, orbits very closely to Pluto and is also very big in comparison. This means that the barycenter of the two objects, or in other words, their center of mass, is outside of the primary object. They actually both orbit around a point in space. Not only that, but both objects are tidally locked to each other. This means if you stand on one, the other won't move from that point in the sky. This is very unusual, because while some moons are tidally locked to their parent planet, the planet is not also tidally locked to the moon. Charon is very different visually from Pluto, being much darker. This implies they are not from the same origin. The rest of Pluto's moons are very small, only being a few miles across. Their orbits are exceptionally circular and are all coplanar with Pluto's orbit. The geology of Pluto is very interesting. The biggest visible feature on Pluto is this giant heart shape, which wowed the world when it first came into view. It has since been named Sputnik Planitia. It is the size of Texas, and it has a strong color contrast to the surrounding area. This is because it is a giant ice plain. In fact, during the flyby, it was confirmed that 98% of Pluto's surface is comprised of nitrogen ice. On average, the temperature on the surface of Pluto is 229°C, which means water ice would be rigid and brittle. On the other hand, nitrogen ices at this temperature act like water ice on Earth, meaning it can flow as glaciers. This can especially be seen around the edge of the heart, glaciers flowing into the gaps around the craters and mountain ranges. The ice plains themselves have giant polygon shapes across the entire area. There also are no craters, which means it must be a relatively new feature, or a feature that is being continually renewed. It is perhaps only 10 million years old. The polygonal cells show ridges on them which are likely caused by sublimation, the process of an ice turning directly into a gas. Although it's not known for certain, Sputnik Planitia could have formed from an impact, and ices filled the crater in from a potential subsurface liquid ocean. This filled-in basin actually causes a positive gravitational anomaly. A gravitational anomaly is where the gravity at one point is different from elsewhere on the object. The ice plane is directly facing away from Charon, which would align it up with the object's tidal axis. Due to the short distance between Pluto and Charon, tidal effects are very strong on both objects. This could be the reason why Pluto is tidally locked to Charon, and the two objects can't look away from each other. Surrounding the ice plains are vast mountain ranges made of water ice, which, when viewed from the side on, look spectacular. Water ice is the only type of ice detected on Pluto that would be strong enough to support heights of several kilometers at this temperature. Among the mountains found on Pluto, there might also be some which are cryovolcanoes, one of the most likely candidates being Right Mons. It is 4 km tall, one of the highest peaks on Pluto, and a big depression is found in the center. Cryovolcanoes could be a contributing factor for Pluto's young surface. Another obvious feature of Pluto is the dark material that seems to be sprinkled on the surface in some areas. The biggest such area is called Cthulhu. It is weirdly reminiscent of a whale in shape, as can be seen in this image. The dark color is thought to be a deposit of tholins, a kind of tar made up of hydrocarbons that have interacted with sunlight. Similar deposits can be seen on one of Saturn's moons, Iapetus, so the process has been seen elsewhere in the solar system. The region on Pluto is much more heavily cratered than the heart, which implies the surface there is much older. Mountain ranges can be seen in the middle of Cthulhu, topped with what is thought to be methane ices. Methane apparently condenses as frost at higher altitudes on Pluto. The last surface feature I will mention here is this region called Tartarus Dorsa. It is an extensive, highly distinctive set of 500 eye mountains that resembles snake skin or tree bark. They are thought to be penitentes. If that is true, Pluto is the only place in our solar system other than Earth where they have been observed. Even on Earth they are very rare, but some can be found in the Atacama Desert and other dry, high-altitude regions. The ones on Pluto are much taller and cover a much vaster area than on Earth. We can only imagine what they look like close up. For me, the most impressive discovery that New Horizons was able to confirm was that Pluto has an atmosphere. And not only that, but the images are incredible. Due to Pluto's small size and weak gravity, the atmosphere appears to extend high above the surface of Pluto, Earth's atmosphere. While being much more massive and dense compared to Pluto, hugs the planets comparatively tightly as the gravity is a lot stronger. The atmospheric pressure on Pluto is exceptionally low, however, roughly 10 microbars or 100,000 1 million times weaker than the surface pressure on Earth. It is theorized that the pressure could increase to as much as 18 to 280 millibars, 3 times the surface pressure on Mars and a quarter of the surface pressure on Earth. If the temperature was to rise and the surface ices would sublime into gases, the process which we've seen in the ice plains. The last time Pluto was thought to have this atmospheric density was 900,000 years ago. At this pressure and temperature, the conditions could even be right for liquid nitrogen to form on Pluto's surface. Some evidence of this might be found here, in what appears to be a frozen-over lake. At any rate, within just 1 year, Pluto's atmospheric density can vary by a factor of 4 due to seasonal variations. That is a massive contrast compared to other solar system objects with atmospheres, which generally stay pretty consistent. The atmosphere consists of the same ices found condensed on the surface, namely nitrogen, methane, and carbon monoxide. The other fascinating discovery New Horizons made about the atmosphere is that it has up to 20 haze layers. Haze layers themselves were not unexpected, but the amount of them was. They can clearly be seen in some of these images, acting like layers of a thin kind of fog. Sunlight can be seen streaming through one such layer in this photo, the shadows from the mountains clearly seen in contrast to the sunlight shining through the haze. The layers do not appear to be level across the planet. Here you can see this haze layer high above the surface, but on this side of the image it touches the surface. On a side note, to me these are the most breathtaking photos of Pluto and I purposefully saved them until last. You can truly appreciate depth and the scale of the mountain ranges. Pluto almost seems like a toy replica due to the extreme topographical relief, but these mountains appear so high because Pluto is so small and its gravity is not strong enough to pull them down. This gives for a varied and impressive landscape and a fitting end to the video. Did you enjoy what you saw today? Watching videos is great, and if you want to broaden and retain that knowledge, the best way to do so is to actively grapple with puzzles and problem solving. That's why for these last 2 videos, Astrum has partnered up with Brilliant.org, a website which is a great complement to passively watching educational videos. You are likely here because you want to learn more about astronomy, and so Brilliant.org could be exactly what you are looking for to really challenge your knowledge and help you learn more. Brilliant offers many well-curated sequences of problems that help you master all sorts of technical subjects. You all like astronomy clearly, which they have a dedicated course for. You might also enjoy their related courses on classical mechanics and gravitational physics. If you go to Brilliant with Astrum, you can sign up for free to have a sample of their courses, and by using that link, the first 200 people will get 20 off the annual Brilliant Premium subscription. That's the subscription I've been using. Brilliant is a perfect fit for my channel, so do check them out. The data New Horizons sent back to Earth will continue to be poured over for years to come. New Horizons has a new mission in its sights though, a flyby of a small Kuiper Belt object known as 2014 Mu-69, due to arrive on the 1st of January 2019. If you want to find out about this mission and also see the dedicated Pluto video I will make in the future, please subscribe so you don't miss out. Also check out the other videos I've made about a variety of astronomy topics.